Hello guys, Assalamualaikum. Welcome to EduVersed. I'm Afra Nawar. I'm a student of Rajuk Uttara Model College. Today we will learn Chapter 6 Structure of Atoms of Class 8. So in Class 6 we have learned about atoms. In Class 8 we will know more about it. First of all, what is atom? The smallest particles of matter which maintain the characteristics and properties of the elements are atoms. Examples: hydrogen atom, oxygen atom, and there are many other atoms surrounding us. And atoms togetherly made a molecule. Then the molecule makes a matter. Molecule: the substances that are made of combining two or more than two atoms to form a stable state are called molecule. Example: oxygen molecule, hydrogen chloride. Both are molecules. It may have the same atom or different atoms or different elements. Here is the structure of an atom. The neutrons and protons make the nucleus here. The protons are positively charged and electrons are negatively charged. The electrons revolve around the nucleus, around the protons and nucleus. So atom is the smallest particle of an matter. These two atoms can make two compounds that may have different elements or the same elements. So about these tiny particles, different scientists and philosophers have expressed different opinions. Now we will know about the evolution of the idea of atoms and their structure. First of all, the Greek philosopher Democritus put forward the first time in 400 BC the idea that all matters are formed of tiny particles. According to him, these particles are invisible, which cannot be divided further. He called it atom. The word atom was stolen from the Greek word. So this word atom has came from the word atomos, that means indivisible. On the other hand, there are two contemporary philosophers, Plato and Aristotle, maintain different opinions. According to Aristotle, matter is continuous and as such particles of matter can be divided into smaller and smaller parts with work limit, atomos, which means indivisible. On the other hand, other two contemporary philosophers, Plato and Aristotle, maintain different opinions. According to Aristotle, matter is continuous and as such particles of matter can be divided into smaller and smaller parts with work limit. But the idea of Aristotle was rejected, and Dalton's idea got acceptance. Based on the experimental evidence, the English scientist John Dalton gave a theory on small particles of matter called Dalton atomic theory. According to Dalton, he said many things about the atoms. Elements are made of extremely small particles called atoms. So the small particles are called atoms. All atoms of an element are same, identical in size, mass, chemical properties. Compounds are made of more than one element. Atoms of different elements combining in simple whole number ratios form compounds. So in an element, all the atoms are same. All the chemical properties are same, but in compounds, there may be more than one element. In compound, atoms of different elements may be present, of different chemical properties. In a compound, there may be different chemical properties of the elements that reacts. In chemical reactions, atoms cannot be created or destroyed. Only their combination can be rearranged or separated. So, as Dalton's idea got acceptance, we can say that atoms can be divided. Atoms consist of smaller particles which are electrons, protons, and neutrons. But to remove the limitations of the atomic concepts of Dalton, later others proposed alternative models of atom. Out of these models, the most accepted atomic model is the Rutherford one. Rutherford and Bohr proposed the models of atom. Rutherford and his co-workers at one stage carried out an important experiment to find out the correct structure of the atom. The results of his experiments are: the whole of the positive charge and mass is confined to a small area at the center of the atom called nucleus. He also explained that most of the space in an atom is empty and the negative charge is carried by the electrons, which have negligible mass and revolves around the central positive charge. Also, Rutherford's model is similar to the model of solar system, but he did not say anything definitely about the orbit of the electrons. So all the mass are present in the center.
So this atomic number is denoted by Z. Atomic number, as you say, is the proton number of an element. Like if you see, here are the atomic numbers of element. In class 8, if you learn up to 20, if you memorize these atomic numbers. Hydrogen 1, helium 2, lithium 3, all these you have to memorize. These are the atomic numbers or the proton numbers. Okay, know the mass number. Mass number. Total number of protons and neutrons present in nucleus is called a mass number, nucleon number. Mass number is also called nucleon number. That is the total number of protons plus neutrons. We know in the nucleus both protons and neutrons are present. So this totally they are called mass number of an atom and it is denoted by A. Note, in an atom, the number of protons, if we add it with the number of neutrons, we'll get the mass number of an atom. So the number of neutrons,
Again, you have to know that the number of protons and electrons are same in an atom. Both numbers are same, unless it is charged, but in a neutrally charged atom, the proton and electrons are same. If you see the example how to find the mass number or the neutron number in the book, page 60, here is given, like in sodium there are 11 protons. We know its atomic number is 11. You have to memorize this. And 12 neutrons. So the mass number, if we add these two, then we'll get the mass number. Again, if you subtract it from the proton number, we will get the neutron numbers. Here you can get the mass numbers. But you have to memorize the proton numbers only. Now we'll know about new concept, that is isotope. Here we check. Atoms of the same elements with different mass numbers are called the isotope of each other. Here atoms of same elements, this means the same atomic number. That is the same atom which have the same atomic number, like hydrogen. This is the atom. But this hydrogen may have different mass numbers. So the same one, the same atom which have the same atomic number, there is the same atom, but it may have different mass numbers. And as they have different mass numbers, their neutron number is also different. So it's called isotope. They are isotopes to each other, these hydrogens, because their mass numbers are different. But isotope, that is the word isotope. Iso means same. Tope means protons. That is the same number of protons. The elements which have same number of protons but different mass number or neutron number. That is the isotopes. Iso means same. Tope means protons. So same number of protons. If we see the example, every hydrogen atom has one electron and one proton. But most of the hydrogen atoms have no neutrons. But some hydrogen atoms have one neutron. These atoms have mass number 2. As they have one neutron and one proton, their mass number is 2. It's 1 and 1, 2. Again, some hydrogen atoms have 2 neutrons and its mass number is 3. As proton is only 1 and neutron is 2, then totally if we get the mass number, then that's 3. 1 plus 2, 3. These isotopes are called protium, deuterium, and tritium. Like if you see this figure, we can understand easily about protium, deuterium, and tritium. What is isotope actually? Hydrogen. There is a hydrogen which have only one proton and only one electron. The electron number is always the same. Electron number will be only 1 in hydrogen, as it's not charged, so only one proton. There is no neutron present here. But in here we can see neutron and proton both are present. That is one neutron and one proton. The mass number is 2, so their mass number is different. Again, there are 2 neutrons but only one proton number. So 2 neutrons, that is 1 1 1, that's 3. The mass number is 3 here. 1 proton number and 2 neutrons, that makes 3 of mass number. So here we have to know what it represents. This 1, we can see this is the proton number of hydrogen, but here 1, 2 and 3 is the mass number of hydrogen. In every atom, the 3, 2, 1, the upper side, it expresses the mass number. In the lower case, it is always the proton number. In every atom, it's expressed like this. Again, if you see your book, we can get more other examples of isotopes in page 61 about the carbon atoms. If you check, the carbon atoms have 6 protons and 6 neutrons normally, but it has 3 isotopes. Again, if we check our books, we can get more examples of isotopes like carbon atoms. It has 6 protons and 6 neutrons normally in the nuclei. Nuclei is the plural form of nucleus. Okay, normally carbon has 3 isotopes. That is 3 isotopes. Normally 6 protons and 6 neutrons. Always the proton number is always the same. But some atoms have 7 or 8 neutrons in their nuclei. So when it has 7 neutrons and 6 protons, the mass number is 13. And 8 neutrons, the mass number will be of course 14. So it's the isotopes because the neutrons and the mass number here is different, but the proton number remains the same. So these are the examples of isotopes. Only the mass number and neutron number will change, but the proton number will be always the same. So actually, what are the use of these isotopes? Actually, these are applied in our daily life. These isotopes actually are needed. There are different uses of these isotopes. So as the number of protons and electrons in different isotopes of an element are the same, there is no difference in their electrical and chemical properties. Protons and electrons are same, there is no difference in their chemical properties. Of course, there will be no difference. Only the mass number changes and the neutron number. Because the distribution of electrons in the atom that are responsible for the electrical and chemical properties. So the chemical properties and all the properties of an atom actually depends on the electrons, the number of electrons. All the electrical, chemical properties, all are changed due to electrons. But the isotopes can be separated due to the difference in their masses. Only due to the difference of their masses they can be separated, like protium, deuterium, tritium, and they can be used in our daily life. And their chemical properties all can be changed, that is, they can be used. Usually, a particular isotope of an element is more abundant because these isotopes is more stable compared to other isotopes. So these are more abundant. That is, a radioactive isotopes. These are used in a daily life. So if you know the radioactive isotopes and radioactivity, what is this? The unstable isotopes radiate different radiations or rays like alpha ray, beta ray, and gamma ray, and they convert into comparatively stable isotopes. Normally they are unstable. This is unstable, but when they radiate, the radiations or these rays, they are converted into the stable isotopes of same or different atom. That may be same or different atom, but they convert into stable isotopes. They can be stable.
So these unstable isotopes, these are called radioactive isotopes. And this phenomenon is called radioactivity. The whole process is a radioactivity, and the isotopes which perform this is called the radioactive isotopes. Examples: 30 phosphorus, 40 carbon, 60 cobalt, 131 iodine. And there are different uses of isotopes. What are the uses of this if you know that? So there are different uses of isotopes. In medical use, in agricultural use, in geological research, in food production or food preservation, it is also used. So these are the 4 uses of isotopes. We use these in our daily life. In book we can see them. Like medical uses of isotopes, application in literature, in description we can learn them. Usually a particular isotope of an element is more abundant because this isotope is more stable compared to other isotopes. Compared to other isotopes, this one is more stable. So these are abundant. As I've given you the examples, so these are more abundant. So they will use properly. Medical uses of isotopes. Isotopes are used in diagnosis and treatment of diseases. If there is a defect in a narrow artery, it can be detected by sending a radioactive isotope through the blood flowing artery. In the same way, the affected cell of a patient can be determined by sending radioactive isotopes. Again, these radioactive isotopes can be used to destroy the cancer-affected cells. So how can we destroy these cancer-affected cells? This can be done by using a ray, that is gamma ray from 60 cobalt. This one is an isotope. So in treatment of cancer tissues, this can be damaged by emitting gamma ray from 60 cobalt. We have seen the 16 cobalt here. So this one actually emits gamma ray that destroys the tissue, cancer tissues, and then it can be cured. Another reason for radioactive materials is to use its radiation to sterilize medical instruments. To sterilize medical instruments is also used. Other uses of isotopes are here, like 30 phosphorus is used in the treatment of blood leukemia. It may come in the MCQ. That is, 30 phosphorus helps in the disease of blood leukemia. 131 iodine. This one also helps in medical use. That is, it prevents the growth of thyroid glands. 131 iodine. These are the uses of medical. And there are some agricultural uses. In agriculture, the radiation from isotopes are used to control insects. Also, it can be used to find out what type of fertilizer and what amount of fertilizer is needed to a specific crop. So to control insects and to find out what type of fertilizer and what amount of fertilizers are used. Again, here 32 phosphorus. How is it used? The solution of this radioactive 30 phosphorus is injected to the root of the plants for enhancing their growth. So their growth is enhanced. The plant's growth is enhanced by injecting 32 phosphorus. This is an isotope. It helps in the growth of the plants also. So this is another use. We can add this point in our exam. Next, food production. Germs and bacteria can be killed by the radiation from radioactive isotopes. Therefore, radioactive isotopes can be used to make food and fruits free from germs. So you can easily make food free from germs. That is, it can also be used to preserve the food, so they can be preserved. There is an example like gamma ray. It destroys all the bacteria here. So the gamma ray that emits from the 60 cobalt, as we've seen before, from 60 cobalt it is emitted, and this all gamma ray kills the bacteria in a food. So from 60 cobalt. Again, another use is use of isotopes in geological research. In geological research, it has many uses. Like We have often heard the news that fossils have been discovered which are many million years old. It can find out from the decay of the isotopes. From the decay of the isotopes, we can easily find out this. From the ratio of the stable and unstable isotopes, it is possible to find how old the fossil is. From the ratio of stable and unstable isotopes, you can find in the exam. It is possible to find out how old the fossil is. Like 14 carbon. 14 carbon. 14 here is a mass number we know. So 14 carbon isotope is used to detect the age of this earth. This is another point. 14 carbon is used to detect the age of the earth. So this is all about the uses of isotopes in a daily life.